Let us consider an interesting problem from domain of functions. So in this session, we are going to find out the domain of this function f of x, that is equal to square root of negative of sine square 2 pi x over 5, right? So here we have to find out the domain of this function, that is all the valid values of x for which this function is defined, right? So in order to find out the domain of this function, we have to make use of some concept from sine function, right? So let us start. So now consider the sine function, that is y is equal to sine say x, right? And here we know that the domain of sine function is the set of real numbers, that is x belongs to r, that is this x can take any real number, right? And the domain of the sine function is the interval that is from -1 to 1, that is y belongs to this closed interval from -1 to 1, where both the endpoints are also included, right? So here we are going to make use of this concept, right? So here we can also write sine x is greater than or equal to -1 and less than or equal to 1. That is, the range of sine function is from -1 to 1, including -1 and 1. Now see, here if we take 2 pi x over 5 as say a theta, right? So if we take theta is equal to 2 pi x over 5, then our function, it assumes the form that is square root of negative of sine square theta. Now let us first consider this term. So here we have sine square theta, and sine square theta is always going to be a positive quantity, because here we have the square of sine theta. And now if we look at this inequality, then sine x is greater than or equal to -1 but less than or equal to 1. So the square of sine x, that is sine square x, must be greater than or equal to 0 but less than or equal to 1, right? So here we have sine square theta, and sine square theta is positive. So from this inequality we can conclude that sine square theta must be greater than or equal to 0 but less than or equal to 1, where theta is given by 2 pi x over 5, right? Okay, so now see this inequality. Now here sine square theta takes all the values from 0 to 1, including here we have 1, including 0 and 1, right? So now if we take any value of sine square theta lying between 0 and 1 except 0, right? Then here we have inside the square root sign, we have a negative quantity, because sine square theta is always going to be positive, right? And if we take any value of sine square theta lying between 0 and 1 except 0, this is an important thing here, because if we take any value of sine square theta lying between 0 and 1 except 0, then that number is going to be positive, and when that number is multiplied with this negative sign, then we have a negative quantity inside the square root sign, and in that case this quantity would become a complex number, right? So here we cannot take the values, those values of sine square theta which lies between 0 and 1, because all the values lying between 0 and 1 except 0 and including 1 are positive, right? And that positive number, when multiplied with this negative number would become a negative number, and we have a negative number inside the square root sign, and in that case we have a complex number, right? So we have to exclude all the values of sine square theta which lies between 0 and 1 except 0, right? So here the only possibility is that sine square theta must be equal to 0, right? So here we take sine square theta is equal to 0, and we cannot take any number lying between 0 and 1 in this expression, right? So here, so now, for example, if we take any number between 0 and 1, that is equal to sine square theta, right? Suppose here if we take 1 over 3, so sine square theta, it lies between 0 and 1. If we take sine square theta is equal to 1 over 3, and if we substitute this value in this expression, then f of x is equal to square root of negative of 1 over 3, because this is a positive number, right? So when this negative is multiplied with some positive number, then we have a negative number inside the square root sign, and this is a complex number, right? So here we have now sine square 2 pi x over 5 is equal to 1 over 3. So we cannot take or we cannot have any value of x for which sine square 2 pi x over 5 is equal to 1 over 3. And similarly we can explain the other values here. For example, if we take here 1 over 2, then sine square theta is equal to 1 over 2, and this is a positive number. When we substitute it over here, then f of x would become negative of half, and this is a complex number. So there is no value of x for which sine square theta is equal to half, so that we can define this function f of x, right? So the only possibility is that sine square theta must be equal to 0, so that this function f of x it can be defined in the set of real numbers. So when we take sine square theta is equal to 0 in this expression, then we have f of x is equal to square root of negative of 0, that is equal to square root of 0, that is equal to 0. And in that case this function f of x is defined for all values of x for which sine square theta is equal to 0, or sine square 2 pi x over 5 is equal to 0. So this function is defined for all values of x for which sine square 2 pi x over 5 is equal to 0. So here the only possibility is that sine square theta must be equal to 0, where theta is equal to 2 pi x over 5, right? So this function f of x is defined for all values of x for which sine square theta is equal to 0, or we can write sine square 2 pi x over 5 is equal to 0, right? So now we have a trigonometric equation here, and we can solve it. So we can now write sine square 2 pi x over 5 is equal to 0. It implies that we have sine 2 pi x over 5 is equal to 0, and the solution of this equation sine theta is equal to 0 is given by theta is equal to n pi, where n belongs to the set of integers, right? So here the solution of this equation is 2 pi x over 5, is equal to n pi, where n belongs to the set of integers. Now here we can write this equation as 2 pi x is equal to 5 n pi, and x is equal to 5 n pi over 2 pi, and pi get cancelled, so we have x is equal to 5n over 2, where n belongs to the set of integers. So this function f of x is defined for all values of x which are of this form, that is 5n over 2, where n it can take the value 0, plus minus 1, plus minus 2, plus minus 3, and so on. So if we take n is equal to 0, then we have x is equal to 5 over 2 times 0, that is equal to 0. Similarly, if we take n is equal to plus minus 1, then x is plus minus 5 over 2. And similarly, we can substitute other values of n to get the corresponding value of x. So the domain of this function f of x, it comprises of all values of x which are of this form, that is x is equal to 5n over 2, where n belongs to the set of integers.